Next thing we're going to look at are loops, and loops are cool. And you can see here in our outline of what we're going to cover in these language fundamentals that we're also going to next, I added in here that we're going to revisit slices after we've learned about loops. But in this video, we are learning about loops. The first place to go is let's take a look at the language spec. And if you look at the language spec, we have 4 statements right here. And so 4 statements are loops. And in the language spec, reading about loops, I still have my headphones on. I'm like, why do I sound funny? It's a little bit late. What time is it? 2:48 a.m. Because there's only so much time. And when you become when you have family, it's like you got family, you have work, you have exercise, and you have sleep. You could have any 2 of those that you want. Family, work, exercise, sleep. Which 2 do you want? Well, family, work. Okay, bye-bye exercise, bye-bye sleep. That's kind of the way it goes when you have young kids. Back to programming. The language spec, sometimes the language spec explains things well and Effective Go doesn't, and sometimes it's vice versa. I do not like the way the language spec explains 4 statements. It's not very consumable. But if we go look at Effective Golang and look at how do you do 4 statements or loops in Effective Go. So right here under control structures, we have 4. So control structures, this was actually one of the questions we asked, job applicants to come teach at the college where I'm tenured faculty. We asked them, hey, explain control structures. Totally simple question. And some of the people who applied couldn't explain it. It's like, wow, how did you get through all of what you studied and you missed control structures? So when we talk about the program flow, the flow of how a computer reads the program code, we're talking about kind of being able to control that flow. Computers will read program code much like we read a book. They read it from top to bottom. And so the control flow, the flow of the program, just goes from top to bottom, and we can control how that flow goes with certain statements. One of those statements would be an if statement, like if this happens, then go this way. If something else happens, go that way. Another way we can control is with a loop. If you have all this stuff, just loop over it, right? Just keep looping. And so that's control flow. So if we look at control flow for a loop, really cool control flow in Go. No while statements, no do while. All we have are for, and that's it. And so with a for, we could basically do all of that stuff. So we have an infinite for right here. We have for condition, right? Why there's some condition. And so there's for init, condition, and post. That's the standard for loop. And this is one of the things I really like about Go. When they're putting this language together, sorry if I talk too fast. People do say that sometimes, but only so much time, and I got a lot to say, a lot to convey. So when they were putting this language together, they were and I'm speculating here because I wasn't there. I don't want to speak for them, but these are just my speculations, my thoughts. When they were putting this language together, I believe they were let's make things as clear, concise, simple, precise as possible, right? Why have while? Why have do while, right? Well, we could do all that stuff with for. Let's just have for, and so I really appreciate that. I'm just going to copy one of these for loops right here, copy that, and I'm going to bring that over to the Go playground. And I'm going to paste that in, right there. Let's see what I've got when I copy it. So for, and then I'm going to copy this, cut that print line and put that in there. And so we have for I is equal to 0, I is less than 10, I plus plus. And if we look at the way that was described, it's described as init condition post. Init condition post. So here we are initializing a variable. Right? So there we're seeing that word initialize, which means it's being declared. I am declaring that there is a variable I, right? That's the identifier. I is the identifier, the variable name, and it is of type, and here the compiler figures out the type int. I am declaring that, and I'm assigning to it the value 0. When we declare and assign, that's initialize. So here's our initialization, and then we have next our condition, right? And here's our condition. And so while I is less than 10, this loop is going to run, and it'll just keep going. And then we have our post. And after each loop, right, there's the post, and here's the post. After each loop, we're going to do plus plus, which means I plus plus is exactly the same as I is equal to I plus 1, which looks totally weird when you're first coming to if you're new to programming, it's like, what? But basically, you're saying, hey, take the variable I, and I want to assign to it whatever the variable I already is and add 1 to it. So if I was already, I is equal to colon equals 0, if I did I equals I plus 1 and I printed that, I would now be 1, right? If I printed it right here, format print line I, not OI, right? If I just had that code right there and I ran that, that's just gonna be, hey, I is 1. Let's just do it. I'm gonna take this out and format all that and run it. And here we've got 1, right? So I is equal to 0. So right there I'm initializing I. Declare that I is the identifier I, the variable name I, is of type int, right? I'm declaring I is of type int. And we're assigning it the value of 0. Declare and assign, we've initialized I, and then we're adding 1 to it, and then we're printing it. I could also just do this, I++, right? And then I could run that, and exactly the same thing. Whoa, cool. So that's the format. Is that all formatted? Good. That's the knit part right there. So we have the initialization. Sorry, that's the post part. And then we have condition, and then we have post. And so the way this works is, okay, first time through, I is equal to 0. Is that less than 10? Yes. Then let's print I. Let's print I, okay? And then it gets post, after we're done with that loop, post, we're gonna add 1 to I. I is now 1, is 1 less than 10? Yes. So let's print that, and then let's add 1 to that, and that's 2. Is 2 less than 10? Yes. Is 3 less than 10? Yes. Is 4 less than 10? Yes. ... Is 9 less than 10? Yes. Is 10 less than 10? No. Out, right? And we could do a format print line here, and we could say done with loop, okay? And run that, and it's going to print out 0 through 9 and done with loop. How awesome is that? That's a loop. All right, so that's how we do a loop. And your challenge for this video is I want you to create a loop that prints from 100 to 1,000, and every number from 100 to 1,000, including 1,000, All right, go do that. Pause the video, go do that, because I'm going to show you the answer right now. To print from 100, I'm going to start at 100, right? And then I'm going to go up to 1,000, and so I'm going to add 1,001. So when I run that, kapow. That's how fast computers are. Well, I got to scroll. Wham, through 1,000. I could have also done why it's less than or equal to 1,000, and I'll let you figure out the logic on that one on your own, and that's going to do the exact same thing. But there's how we do a loop, man. Loops are cool, and we're going to see in the next video how we loop over a slice.